That was just Lisa wanting to know whether we could hear her. And I said no.
Okay. All right. All right, 6 o'clock. Let's go. So welcome everyone. I'm Steve Coleman and I'm based in Churros Head. And along with my co-hosts, there's Catherine Maxwell, who's in Maria, and Frank Muller, who's in Bermagui, and our two fabulous presenters, which are Alan Pearce and Paul Dolphin. I'll introduce Paul and Alan in a sec. We're spread across Bega and Urbadella Shires, and I'd like to acknowledge the traditional owners and custodians of this land. This is Yuin country, so we pay our respects to all elders, past, present and future, and thank them for their care they've given this land for many thousands of years. So we had about 80 people who booked online, and as I look, people are joining up. As we go through the webinar, please use the chat function to ask any questions or to provide feedback. We're recording the webinar, so we'll make that available after the session. Probably not for a day or two. We'll have to sort of figure out how we're going to operate that. Also, Alan and Paul have generously offered to provide their slides, so we'll put those up as PDFs on the website for downloading, and we'll give you information for that. So we've got all your emails, so we'll send you that information as we go through the session. So this is a community-sponsored event, and it grew out of an initial conversation that Frank and I were having in the aftermath of the fires and the scale of the rebuild for the region. And we sort of came up with this basic question of how could we best support people to rebuild and renovate, or even around sustainability, energy efficiency orientation, and Frank will talk more to that in a sec. So Catherine and myself are committee members with South Coast Health and Sustainability Alliance, which goes under a very Australian acronym of SHAZA. Anyway, SHAZA was set up in around 2015 to basically deal with the impacts and challenges of climate change hitting our region. And our key focus has been on practical actions, specifically in the areas of renewable energy, sustainability and community resilience across the Shire. But this is actually spread across 2 shires. So Frank's in Bermagui. And Frank, I might pass to you now just to explain, you know, the background and how you're connected up with the process.
Thank you, Steve, and thank you all for joining us today. The idea of the webinar came out of the Cobargo and Region Energy Transition, which is a group of Cobargo and nearby residents who are working as part of the community's bushfire recovery efforts to develop a more resilient and sustainable energy system. Cobargo was without power for 10 days from New Year's Eve, and some more remote localities only recently regained mains power. One part of our work is development of a plan for the town and surrounding areas to maintain power supplies and hence also communications, water and sewerage during and after future disasters. Another part is helping people who are rebuilding to build back homes that are more energy efficient and so cheaper and more comfortable to live in, as Steve just mentioned. This webinar is the first step in our efforts to help households. It's a joint effort with our host, Shasa, based in Maria, and is directed to households, as Steve said, in both Bega Valley and Urbadella. Another sponsor is the Bermagui chapter of CFI, that's Clean Energy for Eternity. Both Shasa and CFI have helped households through group buys for solar systems over quite a number of years, helped households to reduce their power bills and carbon emissions. The Cobargo initiative has been inspired by those efforts, but also, as our speakers will explain, is looking to take advantage of this once in a generation opportunity to build back homes and other buildings that use vastly less energy and are more comfortable and cheaper to live and work in. These efforts will also help tackle climate change and make our communities more resilient to the changes already underway. I'll say a little more about our future plans at the end of this webinar, and particularly what we have in mind for helping households beyond this webinar. And we'd also, obviously, through the chat function or emails back to us, very, very interested in what suggestions and thoughts you all have about what would be helpful. Okay, I'll hand it back to Steve.
Thanks, Frank. So let's start off with Alan. So I'll just introduce Alan, who's one of Australia's leading energy efficiency experts. So he's worked on energy and green buildings for over 40 years. Not that old, are you, Alan? But anyway. So from policy to rating till development and practical projects. Based at RMIT, Alan was awarded a member of Order of Australia in 2009. And he's just told me recently he's gone off gas at home and saving lots of money. So that's a good thing. But you don't even have a beanie on, Alan. So it's Alan's also in lockdown, and so he's based in Brighton in Melbourne, and he's a recreational non-lycra wearing cyclist. So using Google Maps to map 5 kilometre radius from home to do as many kilometres as possible, I guess, Alan. So look, I'll pass over to you, and thank you, both you and Paul, for donating your time to this evening. Okay. Over to you, Alan.
Thanks very much, Steve. I'll just try to share my screen so we can, right, okay, we'll go there. Right, okay. So, well, thank you for inviting me to speak tonight. As Steve said, I'm beaming from lockdown in Melbourne, where the weather's not too bad just at the moment. And I'm going to kind of do a broader talk, and then Paul has lots more detailed approach, and then we'll have a discussion afterwards. So we'll try and not go over time. I thought I'd start off with my first slide because this is actually an award-winning home developed by Wollongong University students for an international sustainable housing competition a few years ago, and I think they actually won. And it's interesting because in this competition they have to build the house, then pull it apart, then take it to the host country and put it back together. So there's a dimension of relocatability and prefabrication in their work. So I just wanted to highlight that, you know, you've got some pretty smart people working in this space not too far from you. I thought I should try and think about, well, what are the issues that might be relevant for you people? Because I always feel nervous about you know, whether I'm telling you something useful. So I've looked up your climate zones, and there's a fair variation. I recognise that you just had a terrible time with the bushfires, with enormous trauma, and now you're facing the financial challenges of trying to rebuild and deal with insurance companies and adjusting to a new life after the fire and things like that. And that my sister actually lived in the Dandenongs and left her home in the 1983 Ash Wednesday fires when the fire was in her backyard. They were incredibly lucky because they'd built on a concrete slab and sort of dug into the hill. So the fire jumped their house and they were one of only 2 houses left in the street. So it's, I'm very conscious of just how hard it is for you guys. Obviously, you're facing all the kinds of things of climate change, like the increasing fire risk, but beach erosion, flooding, all sorts of complicated things coming through. clearly, as Frank said, you've been confronting the challenges of energy supply, resilience and reliability not being what it used to be. And I think many of us are trying to really work out how can we contribute to a beyond zero carbon society. I guess one thing that I'm seeing in the building space and many other areas is that there's an enormous amount of exciting innovation happening, and that gives me some hope that we can achieve lots of things. Now, we'll have discussion time, so if I haven't covered all the things that I think you're interested in, then we can talk about them later. Okay, just a quick slide on climate change and extreme events. This graph shows the kind of distribution of temperatures that a typical climate in Australia sees, and it shows how we've had a degree or so of warming over the past decades. But the important thing is, if you look at the vertical dotted line at 2 degrees, what you see is that the percentage of the time where we're having extreme events has basically increased by a factor of 4, even just with 1 degree of temperature rise. And I think this is a really, I think it's something a lot of our politicians and business leaders don't realise, is just how quite a small temperature change on average can have such a big impact on the extreme events that we have to confront. So that makes me kind of worried, really. So yes, we're having to deal with all of these things, from higher peak rainfalls to rising sea levels, storm surges, bushfires. It's becoming a fairly challenging time, and it will get worse. But also, there is this issue of the challenges for our infrastructure. For individuals, there's enormous financial impacts, because your asset of a home and land may be worth less if it's in a vulnerable place, and businesses are being impacted by changes, all sorts of things. The psychological changes, impacts that we're all confronting are really significant. And it's not just more natural disasters. I think the uncertainty that we face, again, in the Black Saturday fires in the Dandenongs, and I was shuttling my fragile elderly mother backwards and forwards from the Dandenongs on all the hot days, and it's like, you know, how do people with kids decide whether the kids go to school or whether they take them and all move somewhere else for the day? These things are really hard. And of course, a lot of the supply chains that we rely on for food and all sorts of stuff are challenged by these kinds of changes. Looking at our own circumstances, I think it's really interesting to say, well, okay, it's a good idea to plan ahead and think ahead so that we're not reacting to crises all the time. And so this is one thing I do with people, is just draw up a rough graph and mark, you know, when might we want to have to change our car, or when might we buy a new fridge or things like that. So you can plan ahead and you're not on the back foot if an appliance fails or something like that. This information just gives you a few resources that you can use to build your strategy and think about things. And clearly, if we're trying to cut our emissions, energy efficiency is what the International Energy Agency calls the first fuel, and we should do that first. We can buy green energy, and it's increasingly cost effective. But I think the reality we all have to face is that we don't control a lot of our emissions. You know, if I have to go to work and I don't have public transport, I'm using a car. And so that's where buying carbon offsets is actually quite an important part of our strategy. And it's important to realise that if you buy good quality carbon offsets, you're not just buying someone else reducing their emissions on your behalf. A lot of the carbon offsets are being are contributing to improvement for Indigenous communities in Australia if you're buying their offsets, or for developing country communities as well. So it's actually something that you can make a positive thing. Looking at how people use energy in Australian households, the left-hand slide here shows that in fact we have been becoming more efficient. And you can see the big things: space conditioning, heating and cooling is pretty big, water heating is pretty big, especially if you have electric hot water. And then down the bottom, there's quite a few appliances there that are contributing to a fair bit of our energy use and emissions. Of those appliances, you can see over on the right-hand side, the fridge is pretty big. And also our televisions and IT equipment are also quite a big factor. And then there's a whole lot of other bits and pieces. When we're trying to make decisions about our energy future, it's actually quite difficult. Just to give you some context, I looked up the government's Energy Made Easy website, which allows you to choose the best deals for energy. And you can see that a house in your general area with electricity and gas is probably spending about $2,500 a year on energy, of which, you know, quite a bit is fixed charges. So that's a challenge, because the fixed charges are a bit hard to avoid unless you go off grid. But in fact, as Steve said, I've gone off gas in Victoria recently, and I'm saving $1 a day on my gas fixed supply charges. So that's actually making quite a difference to my budget on energy. So making the right decisions is challenging, because there are lots of complicated things to think about. You know, can I get access to the finance? And I'm paying a high interest rate. Have I got to pay it back fast? And if I'm buying things I'm not familiar with, you know, I might be not very confident that I'm going to get the returns that they say I'll get. Maybe the appliance, if I'm not familiar with them, might break down. And also, the decisions we're making can lock in our impacts and our costs for a long time. So, you know, things we're deciding about our house could impact on our energy and our comfort for maybe 50 years. So it's hard to weigh up all of these things. And in particular, one of the things that is often ignored is the issue of what are called multiple benefits. For instance, better health, comfort, noise, lower maintenance, things like that. And as a friend of mine in the energy space says, you know, look, if you can avoid a few medical appointments, that can actually save you quite a lot of money. So there's lots of ways of looking at these things. The other thing I think is important to think about is how we think about financial analysis. And a lot of people use what we call the payback period as the way of making a decision. And it's actually a psychologically very negative and a very conservative approach, because basically it makes you feel as though you're behind until you've reached that payback period that might be 5 years away. But actually, if it's an investment in savings, you need to look at what's the net cash flow in terms of borrowing the money and then repaying the money. Usually energy efficiency measures will give you a positive cash flow from the day one if you can borrow the money. Alternatively, you can look at the rate of return that you get on your investment compared with the cost of capital, or the return you could get from putting the same money into the bank or another investment. And you'll find a lot of clean energy solutions are very good in that way. Information is really important, and all new homes in East Coast Australia and replacement meters for electricity are now, what are we calling? We're calling smart meters. They're not that smart because they only tell us about information the day before, but nevertheless, they give us half-hourly information, and different retailers will have web apps that you can look at. This is some of my data, and you can see, I can see what happened every day in the top graph, in the bottom graph, that's a half hourly thing. And like the bright yellow is when I use lots of power compared with the dark colours when I use very little. So you can see my hot water service kicking in, and you can see, boy, one lunchtime, I certainly was doing some big things. There's also increasing data analytics coming through. And for example, AGL in Victoria with their smart meter customers can actually analyse your data over time and help you to understand what activities are contributing most to your bills. And also they can help you pick up even things like faulty appliances and things like that. So there's going to be exciting developments in that space over time. If we're looking at buildings, this is a very big overview of kind of the things you might think about. Location is important because it impacts on our need for transport and our access to services. The site tells us whether we've got access to some sun or wind, and the other factors we'll talk about a bit later. So from that point of view, there's quite a lot to think about when we're planning our home. If we look at the basics of energy flows in and out of the building, I mean, basically a lot of energy flows in and out through the roof, the walls, the floor, the windows. A lot of air leakage can add to our costs as well. And essentially, if we're going to try and do things, I've just listed a few of the sorts of things, you know, advanced glazing, shading, insulation, things like that are all really important to deal with. But there are a lot of subtleties too. So for example, if we think about my artistic house here, and you can see where the sun rises south of east in summer and north of east in winter. In the middle of the day in the summer, it's high in the sky. In the middle of winter, it's lower in the sky. And likewise, it sets south of west in summer. So it's interesting to then think about, well, what does this mean for my home? And so obviously, if I've got lots of trees around me, I'm not going to get a lot of winter sun. And so that means if I've got really big windows, they might not gain much solar energy in winter, but they might lose a lot of heat. Likewise, when the sun's high in the sky in summer, we need some good shading. But one of the problems we have is that now it's often hot right into late summer and autumn when the sun is actually starting to get lower in the sky. And with just fixed shading, we may, the sun may come in under it and cook us. Because if we've got a super insulated house and the sun's shining into it, it could make us quite hot. If we're looking at the east, I think it's quite interesting to see. I really like northeast windows, for example, because they'll get the winter morning sun and kick the temperature of the spaces up really well. And at the same time, the outdoor areas on the northeast are protected from the hot afternoon sun in summer. So they can be really nice outdoor spaces as well. So smart shading strategies can allow us to make east windows or west windows less of a problem and more of a benefit if we think carefully about what we're doing. I won't talk at length about the west, but the west is much harder to make work, I have to say. And of course, the south is cooler all year round and doesn't get any real winter sun, So you need to think about that as well. If we look at peak electricity demand in summer and winter, I've highlighted New South Wales here, and you can see that heating and cooling, the grey bit, are certainly big bits of our electricity. At the same time, appliances are big players because we run lots of TVs and cooking and other things like that at times of peak demand, which in summer is typically mid-afternoon, late afternoon to early evening, and in winter is evenings. So you see in winter, lighting is a bigger factor because we've got shorter days. Again, there's a few ideas for doing things and the relevance of the different activities, which I don't have time to go through just at the moment. Appliance energy labelling is a very important factor when we're thinking about buying appliances. You can see there a list that, you know, quite a lot of the major appliances now do have appliance energy labels. And the best products on the market in each area are typically 50 to 80% lower energy consumption than the worst available. And each extra star is about, you know, 15 to 30% savings. So more stars is good. One thing we're finding is that lots of people seem to think that 4 or 5 stars maybe is pretty good. And actually for fridges it is. But for a lot of other appliances, technology change has occurred very fast. And so, for example, the best TVs are 7 and 8 stars. The heat pump clothes dryers are up to 9 or 10 stars. So you need to look carefully, and you can use the government's energy rating website to see what are the most efficient products on the market. Where they're just beginning to phase in a new energy label for reverse cycle air conditioners, which is shown down the bottom there. And this is allowing us to look at which ones will be most suitable for different climates around Australia and in New Zealand, because basically most air conditioners don't work as well in cold weather as in warmer weather, but some of them are designed to work quite well in colder climates. So this allows us to make some decisions there. This is the result of a bit of research I've done where I've looked at what you might call a sort of a typical 2 or 3 person household that's using about 10,000 kilowatt hours of electricity a year. So that's about $2,500, 3,000. And the blue bar shows the average for in 2014. The orange bar shows the average in 2019, and you can see we are making improvements as we improve buildings and have more efficient appliances coming through. And the grey bar is showing you the energy consumption you would have if you bought the best appliance on the market, the best performing appliance on the market, and you know, used it sensibly, shall we say. That's a value judgment, I know, but there you go. Again, the list of information down the side there just tells you in more detail what assumptions I've used. So for example, the clothes dryer, which is a bit hard to see there, is actually an 8-star rated heat pump clothes dryer. It's got LED lighting and a heat pump hot water service and things like that. So, you know, the reality is our choices we make when we're buying are really quite significant. The other thing that's pretty exciting and in some ways challenging is the amazing shift towards digitalisation. And we are increasingly able to more efficiently and optimally manage all sorts of aspects of our homes and get information to help us make better decisions and things like that. And this is really going to underpin identifying faulty appliances and realising if something's been left on and all sorts of things like that that will help us a lot. So I think this is a pretty interesting kind of space we can be in. And, you know, for instance, if you've got if you're catching public transport, you can look at the real-time performance of the transport so that you don't miss the bus, which is kind of good if it's every 2 hours or something. Also, all of this is becoming much more cost effective, and the more efficiently we can manage all of this equipment, the more we'll save, basically, and the lower our emissions will be. And I'll stop there. After Paul, well, we're going to have a couple of questions. Is that right? I'll stop sharing at this point.
Yeah, thanks, Alan. Actually, what we might do is we'll give people just a minute to put in a few questions. We'll do a full Q&A after Paul's presentation, but maybe just there might be a couple of clarification points. So we'll just give people a minute to put anything in that that they're interested in. We'll then, so we'll just have a minute of sort of blissful silence while we get a few questions, and then we'll come back to you.
Where's the music?
That's right.
Oh, we've got a question there. Is that?
Oh yeah. Oh, Catherine, do you want to sort of pick up and run through some of those?
Okay, Alan. Matt's identified an efficient Daycon air conditioner in your room.
Yes.
And he'd like to know, how much did it save on the bill compared to a normal one?
Well, this one's about 5.5 stars, and the mandated minimum. Well, so no, put it this way. No, it's actually 7 stars, but this one gives you about 5.5 to 6 units of heating or cooling for each unit of electricity. The mandated least efficient ones allowed on the market give you about 3 units of heat or cooling per unit of electricity. So this is, 40+% more efficient, 45% more efficient than what you can buy on the market. But, there's a spectrum.
Okay, and Heather's asking a question, are there energy ratings for hot water systems?
This is a problematic area. There are for gas water heaters. They have a star rating, but you have to be careful because they're based on an assumption of 200 litres of hot water use a day. And so if you're a low hot water user, an instantaneous 5-star gas water heater will use much less energy than a storage gas hot water service of the same star rating, because the storage one's got a pilot light and heat losses from the tank, while the instant one only uses energy when you want it. As far as heat pumps and solar are concerned, look, you can look up the Clean Energy Regulators listing of all the solar and heat pump water heaters on the market. And they have a list that shows the number of what they call small technology certificates, which you can basically look up. And the more, essentially that's what determines what kind of rebate you get when you're buying the heat pump or the solar water heater. But what it means is you can actually look that up, and the more STCs that they get credited with, the better the product is, because the more it'll save you, because you're being paid based on the emission reductions. But yeah, look, there's work going on for a standard water heater star rating label, but I have to tell you, the various fuel suppliers have not been enthusiastic about being compared across fuels.
Thanks, Alan. And we've got, has wood heating, this is from Andrew, has wood heating been factored into any calculations?
I haven't looked at wood heating in here, and it's actually very difficult because, like, a lot of people, get some or all of their wood for nothing. Others can pay quite high amounts. And also the efficiencies, the real efficiencies of wood heaters vary enormously, especially depending on how people use them. So I haven't tried to do that, I'm afraid. To put it in context, a kilogram of wood produces about 16 megajoules of heat when it burns, which is about equivalent to 3 and a bit kilowatt hours of electricity, about 20 something megajoules, 25 megajoules of gas. So, that would be, actually, no, it'd be about the same, 16 megajoules. So that would be about, 50 cents of gas. So that's 1 kilogram of wood. So you can get a bit of a feel for that.
I've got a question which I'll read out and hopefully you'll understand. It's from Cecily. It says, PPT available. UOW, University of Wollongong plans available for public. That might be about the house.
Yeah, look, I don't know. I think that at least one of the houses that's been in the competitions is actually on site at the University of Wollongong, but I'm not close enough to know. There's some information, I think, on their website about them, but I think, was it Frank mentioned that one of the academics that's been involved in that program lives somewhere in your general area, and might be possible to actually get them to talk about their stuff and show you more.
Actually, I think it was me, Alan.
Oh, Steve,
yeah. Professor Paul Cooper is a friend of mine, and he headed that project to China. So he's off four-wheel driving in Queensland at the moment. But I can send him an email to see what he says. I think that was from Cecily. That was the PowerPoint available. We'll put it up as a PDF, as a downloadable PDF. So we'll send information out via email on that.
Okay, and we've just got one last question from Heather, the long one. What's the best way to shade large northeast windows from summer sun? And when building, how important is vertical thermal mass in walls versus floors? And should it be north, south, east, or
answer these.
Well, I think maybe we could come back to that question when I've done my
let's do that. Yeah, let's do that in the general discussion, because then we can both feed in.
Yeah, we'll certainly look at that one. Yeah.
Yeah.
Okay.
Alan, just before we go to Paul, I mean, one of the challenges is that we often have technology that sort of does the job, and there's that the cost of transitioning to something new. You know, from an environmental perspective, you're thinking of it's got to use new resources to build something, and so there's this sort of tension that I find about, you know, do I upgrade the fridge? Do I upgrade the washing machine? You know, do I go to an electric car? I mean, money's the issue there, but yeah, is there any perspective on at what point is the crossover?
Yeah. Well, actually, I've been looking at the embodied emissions in fridges recently, and it's about 300 to 400 kilograms of greenhouse gas. So that's equivalent to, say, 400 or 500 kilowatt hours of savings. And if you've got an old fridge versus a new fridge, you could save that in like 2 years. So yes, there is a penalty, but also if you make sure that your old appliance is properly recycled, this, you know, the steel and the metals and the copper and a lot of things like that can be recycled with a very low energy cost, which would further reduce the sort of the barrier in terms of the trade-off in environmental impacts.
Yeah. Okay. All right. Well, we might head across to you now, Paul. So let me just tell you a bit about Paul. In fact, Paul was Shaz's first and only employee. He as a sort of a refugee from England, he arrived on our shores and took up a project role managing our solar bulk buy and various other projects. So it's sort of returning to the fold, Paul. So, but look, Paul specialises in creating livable, low-energy homes with his building design team at Paul Dolphin Designs. And his particular interest is in sustainable housing for a tight budget. And he said that when he's not working, he's mainly playing Lego with his boys, which he describes as a very enjoyable busman's holidays. Are they going to be young architects? Is this your plan, Paul?
Yeah, maybe.
Yeah. All right. Well, do you want to put your screen share on and take over?
Yeah, we'll give that a go. Okay. How's that looking?
Yeah, we need to flip that display setting again.
Okay. Sorry.
Seems to revert back all the time.
Yes.
Okay.
Oh,
Yeah,
if
that
you
one.
go back to that previous format and go down to the bottom, there's a display thing down the bottom.
We're good now. Yeah.
Oh, okay.
Are we good now?
Yeah, good, Paul.
Cool. Okay. All right. Okay. What am I going? I'm going to talk about sustainable housing tonight, and I'm going to try and keep it just basically giving everyone a bit of feedback of how I go through designing sustainable houses. So I'm just going to give you my background, and then I think it's always important to go back and look at what sustainability is, and then discuss livability, and then my sort of guide to how you achieve a sustainable house, an order of priority, and then we're just going to touch briefly on bushfire design, and then I'll conclude it all. Just down the bottom there's a little statistic that people may or may not know. There was a presentation a few years ago in an Australian paper. More people die in Australia from excess cold in their homes than they do in Sweden. So I think that's really important. And having lived in Sweden, and then having lived in Mossy Point, I've never been colder than in an Australian house. So, you know, we've got to design for the cold as well as the hot. Okay, sustainability. So the original description of sustainability is the mix between economic, social, and environmental considerations. And when we balance all three of those, then that's where we get sustainable development. And it's this idea that development doesn't compromise the ability of future generations. And for me, this balance between the three of them, economic, social, and environmental, is really important. You know, we could all go and build mud brick houses and do completely off-grid stuff, but then, you know, how am I going to pay? How am I going to pay for that? Or, you know, what toll is it going to take? Am I going to be able to work while I'm doing that, etc.? So there's always a balance between those things. Just to give you my background, when I was first at university, I was very interested in deep eco-design. And what I would mean by that is really using alternative materials, you know, straw bale, earth shelter design, and really looking at how we could green all the materials as much as possible. I then became a building surveyor, which in England is slightly different to building surveyors over here, but basically means a building doctor, and I surveyed 5,000 houses. And predominantly I was looking at defects in houses. And I noticed that one of the main places where we have defects in houses is when we have a material that's not been specified properly or not been used properly in the first place. So that made me cautious about using untried materials. I then became a senior sustainable designer for a housing association with 15,000 houses. We had amazing opportunities there to trial different technologies and implement lots of things. And then when I moved over here 6-7 years ago, I set up my own building design practice, and we've had hundreds of successful DAs and lots of solar passive eco houses knocking around. So just with talking about the building surveying, the primary defects, when we talk about a defect in a building, really what a defect is moisture in the wrong place. So there's three types of moisture in the wrong place, really. First one is groundwater. Second one is rainwater. The third one is moisture that we produce and then gets trapped in the building. And I just thought I'd drag some pictures out from when I worked in Rochdale in Manchester. This is a couple of houses I went to. Those are cellars in the people's houses. Now those white things in the back there that you can see, that's your gas boiler and that's your electricity meter. And on the right one, I think the electricity meter might be underwater. But basically, you've got to wade through probably nearly a meter of water to turn your electricity meter on and off. So that's not ideal. This is another one. We've got a flooded backyard there. In England, we don't waterproof bathrooms in the same way that we do in Australia. So there you've got a hole in the first floor because moisture's been coming out of a shower that's not been sealed properly. And then this last one, we've got mold. That's probably mold from, well, they're from different purposes. Some are from people breathing and cooking, other ones mold coming from damp outside. But anyway, those are sorts of things that we don't want to see in our houses, and definitely not in ones that I've designed. My philosophy then with sustainable design is to balance all three of those aspects of sustainability that we just mentioned, and really using conventional materials in a sustainable way. So Alan had some really interesting slides there showing how much of our energy is on space heating. So if we can reduce our space heating down to zero, 20% of a building's energy is in its construction, 80% is in its running cost. So we don't need to get too fixed on the materials in which we're building, as long as we get a building which is going to be around for 50 to 100 years and is going to not need to be heated in winter or cooled in summer. So my methodology really is using conventional materials, but using them in a sustainable way. So for example, our thermal mass on the inside, steel, decent glass, decent insulation. And, where possible, choosing things that have a low carbon impact and choosing materials that have a low VOCs, I think is really important. But really, it's about the form of the building much more than the specific materials. And if we use standard materials, we can get our builders to build these buildings cost effectively, which speaks to the economic side of sustainability. Okay, so livability. This is, I think livability was actually a different company's attempt to rebrand sustainability because no one understood what sustainability was. But, there's a big difference between, you could make a house that's completely sustainable. Well, like we said, it could be, made out of mud bricks and be completely, not have any windows, because windows let heat out. So, but it probably wouldn't be very livable. So livability is another way of assessing sustainability, I suppose. Cool in summer, warm in winter, and so that it meets people's needs. And that's really important. If you, there's no such thing as an ideal indoor environment, really. Everybody's different. Some people are sat in jumpers, some people will be sat in t-shirts. So it's really meeting, designing to meet the occupants' needs as they require it. Okay, so what do we need for a sustainable house? Well, put simply, all you really need is two things: a sustainable building designer and a sustainable builder. If you get those two things, you should really be able to get a sustainable house. Our house we built a few years ago, and at the time we built it, it was $500 per square meter cheaper than an average house. And it doesn't cost us a penny to run. In fact, the energy companies pay us to run our house. And so we've achieved a very economic, sustainable design with no additional cost, really. But if we want to just talk about the specifics of design, I suppose this is my order of priority. When I talk about the middle way of design, we're quite fortunate in this environment here that although it does get cold in winter and it does get hot in summer, it's actually also quite forgiving. We have large diurnal swings in both summer and winter, which by that I mean we have big temperature differences from day to night. So what that means is in winter, we can quite often get our solar gain into the house to warm it. And in summer, we often get our ocean breeze and our cool evenings, which allow us to draw the heat out in summer. So our environment is quite forgiving. So some of the more specific things that we might do, say in Sweden or somewhere like that, we don't need to do here. And, you know, if we have one unit of insulation and that stops 95% of heat loss, then we add another unit of insulation, that's 95% of 5%. So there's quite quickly a diminishing return on some of the things we do. So again, we kind of go for the middle way. Let's hit the things that matter most and are most cost effective, and then, you know, work our way down that. So those 8 items there are my my order of priority, really. So number 1, orientation, shading in summer, solar gain in winter. Alan's already spoken of that. He showed us that great picture of where the sun is. This is a picture of our house in winter, so you can see that that sun is getting into those rooms and warming them up. You can also see there that we've got various different methods of shading. So we've got eaves, we've got fixed shading on the side of the office there, that orange vertical screen, and we've got a freestanding shade as well. And then there's just another image here, which that's again a winter's day, but you can see where how the sun is getting into those buildings. So our orientation is really crucial. You don't need a true north orientation. You can go northeast, northwest, and you can do different things with that orientation. So for example, if we go back to this slide here, this is our snug media room, TV room, music room, and we actually overglazed the west on purpose so that in winter that would be really warm, you know, and so on a day like this, that's really warm, we don't need to heat it. And in summer we just fixed shading over that. Okay, the next thing is slab on ground. So thermal mass is really important in regulating temperature. Thermal mass, it acts like a ice block in an esky or a pizza stone. So it basically will absorb heat, and then when the space cools down, it will release that heat. So that's what it's doing. It's taking the peaks and troughs of extreme hot days and extreme cool days. You'll notice that we have vertical thermal mass walls. So that speaks to the question before. There is a maximum thermal mass you can have, and you can end up with too much thermal mass. So if you think thermal mass has to be charged before it gives out heat, then you can, if you have a reverse brick veneer or a double brick house, then you can end up always having to charge that and actually having to actively space heat the building, because the solar gain will not charge up that thermal mass. We have slab on ground and we have thermal mass walls. We have one wall per habitable room, and they get that north sun in winter, which you can probably see almost from that photograph. I would say that is probably the maximum thermal mass you want for summer. It works perfectly in winter. It's close to the limit for the maximum in summer. Oh, sorry, I should just say about slab on ground as well. Slab on ground is also really important for engaging the house with the ground. So the ground stays at a regular temperature much more than the air does. And so that works to keep the building warm in winter and keep it cool in summer. Whereas if you disengage the slab, so you have a raised floor, then that space under the building, particularly in winter, is permanently cooling the building. It's much colder. Can work well if you have the building off the ground for really warm places. But I think that the balance here is really good for slab on ground, and our BASIC certificate, the environmental certificate you need, reflects that as well. Okay, double glazing. A lot of people ask me about double glazing. Double glazing should just be standard, really. It should just be illegal to put single glazing in my opinion. It's not really a debate. A lot of people ask though about double glazing's benefit with keeping heat in or stopping heat coming in. One of the key things about double glazing versus single glazing is convection. So it comes back to livability. If you've got a single glazed window on a cold night like tonight, go and sit next to it and see if you feel cooler. And you will feel cooler because it's actually creating air movement over your body, and it's acting like a fan. So when you put a fan on, you're not, it's not making the air any cooler. It's making you feel cooler by passing air over you. And that's what single glazed windows do. So they create much more convection in the internal space and will make you feel a lot colder. So a double glazed house feels a lot warmer, irrespective of what heat is traveling in or out of the building. So when we identify, let's do it. We've got a good orientation. We've got a slab on ground. We've specified double glazing. Then we've got roof insulation and wall insulation. Roof insulation, I would always go with as much as you can fit in there. Wall insulation, wall construction, again, this is sort of really, we're kind of getting, if we've got all those other things working, this is not as important. I mean, probably everyone's had the experience on a hot day when you go and, you know, you're down at the markets and you get yourself in some shade, you immediately feel cooler. You know, so it's about shading our building, and our wall insulation and construction is not as important as some of the other factors. What I would say though is I would avoid too much thermal mass on the outside. So avoid bricks, too much concrete, that sort of stuff on the outside of the building. Lightweight structures work really well here. They work well for cooling down, and they work well in winter. So, you know, FC sheeting, Colorbond, WeatherTex, that sort of stuff works well. Okay, water heating, solar PV, space heating. Water heating, this is a picture of a sand and heat pump. I would go with a sand and heat pump every time for hot water, not standalone solar hot water anymore. You don't really need it. A sand and heat pump with solar PV is going to be far more effective. When your heat pump has heated up the hot water for the day, then your solar PV can carry on generating electricity. Space heating is an entire subject on its own. Hopefully, if you have a nice solar passive house, then you shouldn't really need much space heating. We don't have any, we have a small heater, which we use on occasion. And often we would recommend to people put the wood heater on the plan, but you might just want to wait for a year or two to see if you need it. And again, that speaks to how people actually feel in a space. But really, we don't, in our particular climate, we don't really need too much space heating if we design the house correctly. Okay, this was another question, rebuild or renovate? So I often get asked this, and I suppose, you know, it's that classic answer, it depends, but really, these are just some points to consider. You know, does it have good bones, a good orientation? If it doesn't have good orientation, or if it's, you know, not well constructed in the first place, no slab on ground, no opportunity for thermal mass, then, you know, you might get a better outcome from demolition. The embodied energy, you know, as Alan was just saying about, you know, recycling materials, you know, a lot of the house will have, the metal will get recycled. If there's brick, it'll be crushed for aggregate. You know, and often when we renovate houses, the livability, the outcome, there's often compromises, you know. And if you're adapting a building, it's an inefficient way to construct. You know, a builder will always charge you more for a renovation because there's more cutting, measuring, mixing, matching. So it's not necessarily a very efficient way. And, you know, to give another analogy, you know, would you try and put the guts of a smartphone in an old telephone? You know, in some senses, if you were to demolish and start again, you would get a better outcome having said that, you know, there are often houses that we can renovate, and it really does depend on the specifics. But you know, good orientation and a decent amount of house that you can keep is really important. Okay, my final thing for tonight is just the bushfire conversations. I don't know how many people have been affected by the fires who are attending tonight, or people who are thinking of building in bushfire zones. Basically, when you're building to bushfire construction, you have a thing called a BAL rating. And that is, it's basically 12.5, 19, 29, 40 and flame zone. And that's basically dependent on your proximity to vegetation that could burn, basically. And there's a few variables there, like the slope, the type of vegetation, the area you're in. Basically, you have to clear around your house, you have to clear an APZ. As the APZ increases, so your BAL requirements go down. So if you can get a really, really big APZ, so it's a nice cleared area, then your BAL could be really low. If you're in managed land, suburban area, then your BAL could be really low. But if you end up with your vegetation almost brushing against your windows, then you might end up in something called flame zone, which is very costly and very difficult to build in. With the exception of flame zone, I don't think there's much impact that a BAL rating would have on your sustainability. So it's only going to change the external materials you can use. It's going to impact how much you have to clear around your house, and it's going to impact the toughness of the glass. Other than that, we can still have our same orientation, slab on ground, everything's the same. So it doesn't impact too much on sustainability unless you get into flame zone, which is incredibly difficult. If anyone's got any questions about that though, I can help you with that. So just to conclude, remember those three aspects of sustainability: environment, social, economic. Consider livability, how you want to live in your house. And remember the middle way. It's not all about, you know, straw bale and deep eco if you can't afford that or you haven't got the time. You know, if we use conventional off-the-shelf materials, we can get a sustainable outcome. And just think about that order of importance that I just talked about. And that's everything. Thanks for listening.
Thanks, Paul. That was great.
Okay, I don't know how to stop unsharing now.
So there was a question from Nina, just asking you if you could explain your thoughts again about the heat pump versus solar PV.
Okay, all right. So if you think about what Alan was speaking of, we want our house to be fully integrated, okay? So if you spend $4,000, I don't know, if you spend $4,000 on a solar hot water system, when it's done charging up the hot water for the day, that's all it does. Whereas if you have a heat pump and that costs you $2,000 and then you spend the extra on solar PV, your PV is going to generate the electricity to run the heat pump. When it's finished running the heat pump, it can then run other appliances, it can charge a battery, it can charge your car, or it can go back to the grid. So it's a more efficient way of doing it.
Can I add to, for me, speaking as a Melbourne person with a heat pump water heater, in Melbourne, solar hot water does not work very well in winter, whereas the heat pump will give you almost the same performance in winter as in the rest of the year. And so particularly if you're trying to go off grid or something like that, then winter's the time when you haven't got much solar energy, and the heat pump will work a lot better in winter. Also, friends of mine have problems with their solar overheating in summer. And again, the heat pump unit just heats the water up to the thermostat setting and that's it, and switches itself off. So you don't have to worry about things like that, or getting up on the roof to clean the panels and things.
Yeah, so that what Alan said there is really important. So solar hot water, if you need to boost it, then you need to have either an electric element or a gas backup, which again knocks out the efficiency of it. And I think heat pumps used to have to do that before they could run below zero. But now, you know, the standard heat pump will run down to -15 and still give you 2.5, 3 units of hot water for every 1 unit of electricity. So you don't ever have to go to a standard 1-to-1 immersion heater or gas heating. And that's what makes the heat pump really efficient as well.
Actually, there's a question here that I'm from Queensland. Won't hold that against you, but what is a heat pump basically? Alan, do you want to tell us the technology behind the heat pump?
Yeah. Well, look, your fridge is a heat pump. It extracts heat from inside the cabinet and raises its temperature and dumps it into the kitchen. So the sides of the fridge or the back of the fridge feel warm when it's running. So essentially a heat pump pumps heat. And the reason why it can be so much more efficient than, say, a resistive electric heating element or something like that is because the heat pump is not creating heat. It is extracting heat from one place and sort of raising its temperature and then sending it out somewhere else. So I use the example of the compressor in a heat pump is a bit like a bike pump. You know, when you pump up your tires, the bike pump gets hot. Well, that's what the heat pump is doing. It's compressing the refrigerant and making it hot, and you can then use that heat, and then it just cycles around and picks up more heat from the cold place. Also, a lot of people wonder why when it's -15 degrees, you can still get heat out of a heat pump. The reason for that is that the laws of thermodynamics don't work from a base temperature of 0 degrees Celsius. They work from a base temperature of the temperature of outer space, which is -273 degrees. So even cold air has a lot of heat in it, which your heat pump can draw out if it's got the right refrigerant, like the carbon dioxide refrigerant that the Sandon that Paul's mentioned has.
Can I just answer a question that I've seen just pop up there, just on that? So that someone said, can it be air conditioning or hot water system? Yeah, so a heat pump is just moving heat from one medium to another medium. So you can have an air sourced heat pump, which is air to air. So that's your air conditioning unit. Or you can have air to water, which is the standard heat pump we're talking about. Or you can have ground sourced heat pump. So you can source it from under the ground into air or into water. So there's lots. So the heat pump is just moving air from one place to the other, and yet it can take different forms.
Okay, Frank or Catherine, do you want to follow through on some of the points that are coming up and maybe pose a question?
Yeah, I'm happy to follow up on a couple of them. Gil from Wandella, I think, asked about someone being able to go over his plans, having arranged a designer and got some plans for a sustainable house, and just wondering, I think, whether they've hit the nail on everything. I should mention that for people in that situation, but also for people who are still thinking about or haven't completed their design, there is an organisation called Renew, based out of Melbourne, that is hoping, it has received a grant, and it is hoping to be able to provide one-on-one advice like that to people in a 1-hour session initially, and then possibly more detailed advice. They've only recently got this grant, and the timing may not work for everyone, but we're certainly, we've been putting them in touch with the local councils. They often work with councils, and we're trying to arrange or help them get active in Bega Valley and Eurobodalla. So I suppose all I can say is stay tuned on that. I'll let Paul deal with the specific request to him. But there's another question I was going to mention is about refrigerants when fridges are recycled. And please, one of the other panelists jump in if they know more about this, but I did a quick Google, and Planet Ark is saying that only about 30% of the refrigerants in Australia are captured. It's something more like over 80% apparently for air conditioners. There are programs to take your fridge and take out the refrigerants, but I haven't been able to work out how available they are in this part of the country. There's certainly nothing on the Bega Valley Shire Council recycling and waste app about fridges. Alan, you could talk about that a bit?
Yeah, it's really annoying. I mean, to put it in context, the really bad refrigerants in fridges were phased out in the mid-1990s.
Yeah.
So most fridges today have what are called HFCs, which don't eat up the ozone layer, but are still quite active greenhouse gases. I did some quick numbers. I reckon the amount of HFC in a fridge is probably about 150 kilograms of greenhouse gas. So it's significant, but again, if you're on the grid and you're buying a new fridge relative to the old one, that's like less than 6 months, or 6 months or so trade-off. What's now happening is that virtually all fridges now, for the last, I don't know, at least 5 years, have actually been using what they call hydrocarbon refrigerant, it's actually purified LPG, and it has a very low climate impact, and it's not really an issue anymore. And the reason why the manufacturers have shifted to hydrocarbons is basically because the fridge is more efficient using the hydrocarbon than the older refrigerants. So it's not really a big issue kind of on an ongoing basis. So if you're buying a new fridge today, you could check, but you'll find most of them are hydrocarbon. And so the refrigerant's not a big issue into the future. It's really the older ones, and they should recycle it, and they don't.
In New South Wales, the EPA has a program actually with the air conditioning companies. So the EPA is onto it, and it is in all council areas that they do have a program to capture the emissions. Now, Steve, there's a couple of questions around slabs.
Oh, yeah.
So we have one about, is insulating under the slab desirable in this area, but also your thoughts about the slab directly on the ground versus under the slab insulation, and in what situations
Sorry, you've broken up.
under the slab insulation be necessary? Oh, did you get that, Paul? My internet's
so
okay, I'll just take that.
Oh.
Did you get that, Paul?
Yeah, so question about whether you should put the slab on the ground or use under the slab insulation. Really, I think if there's a benefit to having the house engaged with the ground quite often in our more temperate environment. When you get up more alpine region, then that's slightly different. Often you will end up, if you go with a waffle pod slab, which is actually large blocks of polystyrene, you can end up with quite a large amount of insulation there anyway. But really, having your slab engaged on the ground is really taking out basically one element of one elevation of the building from those big temperature swings. So I did do a lot of work into the physics of this years ago. My answer now would really be prioritize all the other things and don't worry too much about that if you're living by the coast. Someone else had a question about sloping sites where a slab is not possible. Yes, you can, if you were to have a suspended timber floor or any form of suspended floor, today I would advocate that you get that insulated for sure. And that's going to That's going to address that cold pocket of air underneath the building. And then if possible, try and get your thermal mass in another way. So, you know, a concrete benchtop, kitchen benchtop that gets the sun, or tiles on your concrete floor, sorry, tiles on your timber floor, or a thermal mass wall if the engineering allows. So yeah, thermal mass is not, you know, the be all and end all. And again, even some thermal mass is better than no thermal mass.
Okay, we had a question that actually came in on the last session, and this was about what's the best way to shade large northeast windows from summer sun? And when building, how important is vertical thermal mass in walls versus floors? And should it be on north, south, east, or west walls? Paul.
Okay, so thermal mass really, in order for it to work for free, it should be heated for free. So it needs to engage with the sun. So it you know, either directly or pretty closely, pretty indirect, you know. So if you have it on a southern wall and it's never getting any sun, then it's not going to work for you. It's only going to store cold, basically, and it's probably going to get damp and moldy. So in our case, we have one thermal mass wall per habitable room, and they are north-south facing. So each side gets warmed by the sun. That's that's disengaged from the outside of the building. So it's like our ice block in the esky. It's inside the building envelope. I like the look of concrete block walls. I like the look of a thermal mass wall. I don't think they're necessarily important as long as you've got a slab on ground. And like I said, I think so you can end up with too much thermal mass where you have to actively heat the building in order to charge it up. And similarly, when we cool our buildings down in Australia, we use a big diurnal swing. So what we need is, as soon as that ocean breeze comes through at 4 o'clock in the afternoon, open all your windows, get your cross breeze through, and get that building cooled down. If you have too much thermal mass, it won't cool down by the time the sun comes up again. So you get, if you've ever spent a summer in an English house in a terrace street where it's double brick, double brick, tarmac, concrete back gardens and everything. And it honestly, it just gets so hot because you cannot flush that heat out. So we can quite easily end up with too much thermal mass, which again is nice, you know, which our Australian form of construction, fibro sheeting, colour bond, weatherboard, works really well for our climate.
A couple more questions. I'll give you a couple of questions, Paul. First is the cost per square metre of straw bale compared to a standard brick home. How do you tell if a builder is sustainable? And how do the best use of the $25,000 rebuilding grant when you have to sign a contract by the 31st of
Okay, all right. Okay, yeah, I got that. So the first one, how much does it cost to build a house out of straw bale? My answer to that would be, how long is a piece of straw? I don't know. See, the thing with, so if we go back to the work I used to do when I was really interested in alternative forms of construction, the problem with those is they're very, very labor intensive. So straw bale, earth sheltered construction, mud brick, all those things, they're great, but you have to do them by hand. So if you're going to do the labor, that's great. It'll be cheap. If you're going to pay a builder to do it who's never done it, he's got to train himself to do it. He's got to anticipate the risk, and he's got to anticipate how long it's going to do. So it's going to cost you more than something he already knows. And so it's more labor intensive. It's more risky, but also if you don't detail it correctly, then where's that moisture going to end up? When you're you know, if you have a straw bale wall against the waterproofing of a bathroom, any moisture going into that can't breathe out that way. So after 10 years, is that going to be moldy and damp? You know, it's quite a challenging thing to work with those natural materials and the modern materials and solve where those defects might come. So that I'm going off point there, but I can't answer that question. What you would have to do is get a design done and then get a builder to quote it. The next question, how do you tell if a builder's sustainable? Well, there are some builders who have sustainable accreditation. But I remember when my sister-in-law had her house built and she asked the builder for double glazing and he laughed at her and then just walked off. So he's an example of a non-sustainable builder. Yeah. So really it's about conversation. It's about, you know, if you're interested in the things that we're talking about tonight and you talk to a builder and he goes, yeah, great, I've just done this, I've done that. You know, it's a relationship and it's a conversation, really. You know, references from previous jobs, accreditation. So Green Homes Australia, that I do a lot of work with, they've got an international accreditation for sustainable construction. So I think they're the only people in Australia to have that ISO. So yeah, do your research on them, really. Have conversations with them.
And talk to their former clients and check them out that way. Because, there's a big difference between the talk and the walk, isn't there, Paul?
Yeah, for sure. And then just that last question about the $25,000 grant. I think that $25,000 grant is maybe a little bit like grabbing one of the teddies in the claw machine. It's kind of designed for you not to get it, basically. It's almost impossible to get that grant now. You know, there's probably going to be no one who can start your drawings now for 3 or 4 or 5 months, which takes us to the end of the year. But even if you've been doing your drawings, councils are taking 3 to 4 months to approve your plans. So really, I think there was an article last week that about 100 people have got that grant so far. So it's pretty pointless, really. So I would really just sort of think of it as, you know, that claw and just walk on, and no one's really going to get it.
Okay, look, we've just got a few minutes left. Maybe just one more question, and then we'll just start to wrap up.
Steve, there's a couple of questions on heat pumps I could quickly answer. Someone asked about having them close to the ocean. Well, over 5 years ago, I built one put one in very close to the ocean, and I have had no problems at all. I have had to keep an eye on rust on the casing of the compressor, and that's just like any rust problem. You can manage that. Someone asked how much power it uses. Well, I actually replaced a solar water system that the pump kept failing, and I was relying on a 4.3 kilowatt electric booster. This heat pump is 1 kilowatt. It's a very good Sandon heat pump, and it's 1 kilowatt, but it's barely ever running. So, yeah.
Yeah. So if you think about like a normal electric hot water service, maybe a lot of people might use about 10 kilowatt hours a day. The good heat, the carbon dioxide heat pumps, the Sandon's one, there's another one called Reclaim, which is pretty good. They are basically using a quarter as much electricity to deliver the same amount of hot water as an older electric hot water service.
That's a pretty compelling argument, isn't it, Alan?
They're pretty good. I've got one.
I've got one.
I've got one.
I've got a Sandon.
I think I'm the odd one out. I've still got solar on the roof. Yeah.
So 80s, you know, so 80s.
Oh.
Thanks. All right. Look, we're not going to get to all of the questions that have come through, but I'll put in the chat which I think everyone should be able to see. If you've got any specific questions for Alan or Paul, if you send them to zoom.shazza@gmail.com, we'll forward those out to Alan and Paul and Frank, etc., so that they can respond to them as appropriate. So, look, thanks everyone for coming along. I might just pass to Catherine just to talk a little bit about some of what Shaz is doing in the community and some of the projects that we've got running. You might want to get engaged in.
Yeah, I thought I'd stick to things around the topic. So a couple of things. One, we've been running a solar bulk buy now for 3 years in partnership with a Badella-based solar company called Micro Energy Systems Australia, or MISA. And we've installed over 250 solar systems and about 1,200 kilowatts of panels. And we've got pretty happy customers. So if you want to go through, I suppose, a safe process with a good pair of hands and a good local company, have a look on our website. There's information there. And the other thing that we do, and this is particularly helpful for people who do want to retrofit, is we do energy assessments. It's a $99 fee. We've done over 20 residents in the past 20 years. We provide a detailed report as well as install LEDs, shower heads, door seals and weather seals, over the last 2 years. So that is a service that we provide. We basically don't make any money out of it, but it's a way of getting some advice tailored to your specific house. And I'll just get Steve to put the email in there. It's the contact @shazza@gmail.com if you're interested. But as Steve did say, we do lots of stuff. So have a look at the Shazza website. We've just updated our website and it's pretty informative. And if you do want to get involved and learn more about, sustainable living, we always welcome new members, even just getting on our mailing list to get our regular newsletters if you just want to be kept up to date. So thanks, Steve.
Okay, and Frank, do you want to just tell us a bit about the Cobargo initiatives and what's happening?
Yeah, well, as I mentioned, there's the long-term vision, which is really going to be a study at this stage. And if people want to get involved in that, do send us an email through the avenue Steve mentioned. But I just wanted to say, in terms of the working with households that are rebuilding, there's three kind of ideas we have for next steps. The first I've already mentioned, which was helping Renew to do these one-on-one consultations, and they're also building up a website that will be a helpful resource. Secondly, Choice is interested in assisting people who are rebuilding, and Choice does also provide energy ratings for some appliances, but they can also help you find appliances that are good appliances. So it's not just an efficient fridge, it's a fridge that works well. So all I can say is stay tuned about how Choice will get involved. And then thirdly, we have discussed the idea of doing a webinar a bit like this, but specifically focusing on heating and cooling and particularly the equipment, perhaps focusing especially on split systems. Secondly, water heating, and then you get into heat pumps and other options there. And then thirdly, the major appliances that use energy, fridges, water, washing machines, that kind of thing. And so stay tuned on that. But if people think that's a good or bad idea to run that webinar, please let us know. Thanks.
Okay, Frank. All right. Well, if this was a live event, of course, we'd give you a big round of applause, Alan and Paul. So virtual claps go out to you. Thank you for your expertise and particularly donating your time to us as a community organisation. I think it's been really valuable, and I hope everyone's got questions answered and taken away some really useful tips and tricks. And yeah, once again, if you need to, get in touch with us and we will pass information on. So we've recorded this and it should be available. We'll link it through the Shazza website. So we'll send an email out to folk letting them know about how to access it and the resources available. So thanks, and make your way into the evening, and stay safe in lockdown down there, Alan. Okay.
Thank you, everyone, for your wonderful contributions tonight and all the questions from the attendees. Thank you.
Okay, thank you.
Bye.
Bye.